Spring 2025. A group of random people accidentally bump into each other in DST class. Even though we have different backgrounds and interests, somehow our collaboration taught us the importance of teamwork. Not a dream one, but as the most committed fellows toward achieving final goal ever. It all started from a primary pain point experienced by dormmates, particularly in Khoi dorm, with his roommates on a random morning. As we defined our problem, we held our first consultation with Taekin, which promised to research existing wristband items on the market. We considered various factors such as shape, size, colors, and components. Ultimately, we decided on a rectangular display complemented by a silicone strap and two attached vibration models placed along the strap. Then we started our first prototype with cardboard, some kind of stuff that we looted from the market space, like the battery and something that we assumed to be the vibration models. A lot of hope for our final result, like a lot.
Upon receiving the components, Khoi began to explore the secret design as we worked on creating the secret diagram. To our surprise, we discovered that our display was a comprehensive unit that integrates ESP32, Wi-Fi, and also the Bluetooth functionalities. However, we are not satisfied with the complexity of the secret diagram, which we found to be over-intricate. Meanwhile, Lin and Ngon tackled the display, which was quite complicated, particularly in terms of functionality. We need to find the appropriate library and download it, a process that took us over 4 hours to complete. After what felt like forever, the code was finally uploaded, and we began the process of coding the display. Như and Thục Anh focused on the strap and circuit holder, sketching, and measuring the dimension meticulously. For the strap, our initial material choice was silicone, but we also considered the assembly and even contemplated manually crafting the silicone ourselves. Miserably, we found ourselves stuck in the material selection process for too long. Then we booked Anh Nhân, our trusted hero. He assisted us in refining the circuit diagram, make it much cleaner and more efficient, thereby optimizing the space for battery and vibration models.
Như started to sketch on fusion based on the former consulting. With lots of struggle at first, we had to measure every corner and every shape, since we wanted to maximize every space for a comfortable circuit holder and strap. We had to move from the makerspace to the nearby computer hub to continue our sketches. After finishing our sketch, we used the 3D printer to print the first model, the second, and the third. And to be honest, I actually lost track of how many failed models we have printed. Finally, the perfect prototype model was born ever since. We then sent it to the manufacturer for production, opting for the TPU for the circuit holder and a flexible material for the strap. Returning to the display, we were now able to code it to show the time and display text as desired. Thanks to the support from Taeyu, our friends from other teams, and our late-night coding sessions filled with hope and determination. We then proceeded to test the vibration models based on the code, and to our delight, they performed strongly and successfully.
However, the worst thing happened. The display cracked due to our carelessness when removing it from the circuit holder prototype, and the strap we sent to the manufacturer turned out to be too rigid and brittle, resulting in breakage. We convened an urgent meeting to devise the solution. We decided to utilize the ESP32 and the separate display to conserve our limited budget. And thanks to Taekin, who gave us a display originated from his previous term student, and ESP32 from the makerspace, We all had the necessary components for this emergency. We also bought this Shopee strap one, which is guaranteed to be produced by real silicone and was actually cheaper than the strap we had sent to the manufacturer. Here comes our makeshift solution. Really ugly, but it works though.
We actually dispatched another script from Go, executed us out in unexpected turns of events, leading to a successful integration of the ESP32 within the display. We proposed an innovative idea to utilize our limited resources to create a product that vibrates every 20 seconds, requiring users to download Arduino, upload the code, and adjust a countdown timer to a specific hour for the vibration to occur. While this approach may seem cumbersome, we plan to update our product's feature in another universe. We finalize our product by using a hot glue gun to secure the solder connection, followed by testing the vibration functionality and connecting the staff to the circuit solder. And that's wrap up our journey with smart vibrating wristband arm. Thank you for having us.